Hello, welcome back. This is Jeff Byers, and this is Annie 255, and this is Module 2. We're going to start working on our sparkler effect, simulation. So we're going to kind of go through all of the emitters, and that's the idea. That's the objective, is to go ahead and we went from emitting particles from an object, a surface, so now we're going to do it. We're going to use some of the emitters with the legacy particle system. So let's go ahead and look at the scene. This is the scene that I want you to create. And of course you guys can go, I always want you guys to go above and beyond. You guys can go ahead and add real textures. I would suggest that you go in and add new materials first, and just get a basic block out of the colors you want to use for the walls and the floor. And I would use Maya Blend. This works best for preview purposes. Arnold previews are really dark, so if you want to use like a wooden texture, you don't need to add a bump map. You don't need to add a roughness map or a metallic map. Just go ahead and add just one texture map, because we're doing a simulation and we're not going to actually render it. Now, normally if we were going to render this out, we would use Arnold, and we'd want to use a PBR setup, which would include the diffuse map or albedo, or we would use the roughness and metallic maps together and then a normal map. So you don't need to worry about all that stuff. You just need to, if you would like to go above and beyond, all you have to worry about is getting maybe a texture on here that looks like wood or marble or something that looks more realistic than just a regular material. Now, for just an example, I'm just going to use materials for this particular demonstration, just to keep it simple. And you can do the same thing. I mean, you can do all the dynamics and do the simulation, get it working just perfectly, and then you can add textures to the objects if you want to. It's not a big deal, whatever you'd like to do. But the minimum is to get 10 points is to get this set up right. Okay, so I've got a floor made out of a cube. Okay, I've got walls made out of a cube. Okay, and I could have easily used a plane. Now, the reason why I don't use a plane is because particles don't do well with a single plane. Okay, that means the collisions don't work as well as if you use something that has two sides to it. Okay, it's a solid object. Okay, the problem with a plane, if you look at it, if you make a mistake, let's hit the 4 key so we can see what the heck's going on here. Let me get out of here. And we have a plane here. Let's bring that up. Alright, so we have two sides of the plane. Alright, one is rendering, the normals are rendering correctly, they're going up, and underneath you see that they are not rendering at all. Okay, that means that a single plane will not, the particles will not collide as expected. Okay, I'm not saying they're not going to collide with it. Okay, 90% of the time they will, but a lot of the times they'll collide and then go all the way through. Okay, and those collision errors happen with single-sided polygons, so we don't want to use that. We want to go ahead and, when you build your scenes, just think about that. If you want objects, particles to collide, and you want the objects to collide with themselves, you'll need to use solid objects, not single-sided polygons. Okay, so I want you to create a floor and two walls, a table, okay, with the top separated and the legs together, combined. Okay, and then you're going to create a sparkler. Okay, just focus on that a minute. And how I did this is I just created a cylinder, created a sphere, and just cut the bottom of it off, put them together, and then at the bottom I just tapered the cylinder to go into another stick. So these are like two separate objects. Very simple. Okay. Then I took that one there, got it scaled up right, and this would be considered a jumbo sparkler, by the way, and just duplicated it and just kind of created a nice little scene here. Normally you would never ignite a sparkler in your house. That would make no sense at all. So I realized that, but I'm just creating a scene right now. Just, instead of creating an outside scene, let's just create something like this, and then we can simulate the sparks hitting the table and then bouncing off and hitting the floor. That's kind of what I want to happen here. Again, knowing you would never do this in the house, and if you did, you're asking for trouble. Burn your house down. But that's here nor there. So just have some fun with it. If you want to add more, please do. If you want to add textures, I would love that. I would love to see that. And that I consider that to be going above and beyond. So this is what I need you to model, though, just to get it started. Okay, let's talk about scale. So what have we got for scale? Let's go ahead and hit the 4 key and get a wireframe so we can see. So I basically made the floor about the size of the entire grid. So let's take a look at preferences. Let's go into preferences. We know where it is. Windows, settings, preferences, preferences. So here it is. So let's go into settings, and we want to be in centimeters, okay? Most of the time, you're hearing me yak about getting everything in feet to make sure that our renders look good in Arnold, and a lot of renders need to be in correct scale, units and feet or meters. We're in centimeters, so things are really small, and that works best for particle simulation. Now, I believe that it also works good with other fluid dynamic simulations in Maya, so you got to keep that in mind. So make sure you're in centimeter. Every unit here equals 1 foot, so each centimeter, so each grid unit equals a centimeter in Maya, since we're working in centimeters. And so what I'm doing is I'm just converting that over to feet, so each one of these grid units is a foot. Okay, so when I build something, then basically this table is 4 feet wide. Now, in reality, we're 4 centimeters, but I'm just acting like each unit is a foot. Okay, so basically to get the right unit scale then here is that each unit equals a foot, even though we're in centimeters. It will be 4 by 4. Okay, you can see 1, 2, 3, 4 feet, 1, 2, 3, 4 feet. So the table is actually 4 feet. Okay, wide. Now that makes these things at least 2 feet long or 2.5 feet long, which makes them jumbo sparklers. So I've seen those before. It's not out of reality. Okay, and then I think we have 10 units this way, if I'm correct. 1, 2, maybe 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 24 feet by 24 feet for the floor. Okay, I just wanted to get those dimensions correct. Alright, and so let's go back here. Alright, so dimensions are correct on that. Just make sure that you have dimensions correct when we're working with particles. Okay, alright. Anyway, have fun with the scene and enjoy it. So once you get all this done, then you guys can move forward with the simulation. So what I'm going to do is I'm going to stop here, and then we'll go into the next video where we're going to talk about the simulation and how that's going to work and get it as realistic as possible. Alright, so I will see you in the next video.